Welcome to Anova, an acronym for analysis of variance, which is a statistical technique that is used when you're comparing more than two means. When you're comparing two means and below, we usually use hypothesis testing with Z and or with T. But if there are more than two groups starting from 3 and above, we usually use what we call analysis of variance. Now, this is a widely used method in various fields of research when you're doing social engineering and natural sciences. We usually use ANOVA. It is part of statistical analytical tool, which we use in SPSS. Now, ANOVA, or analysis of variance, has a number of key assumptions that you need to look at before you adopt it. So here are the following key assumptions. Number one, events occur independently. So this is one of the key assumptions of ANOVA, where observations within each group are independent to each other. This means that the data points in one group should not be influenced or related to any other. This is a very key assumption. The other assumption is that ANOVA assumes that it is normally distributed. So meaning the distribution of the independent and dependent variables within follows a Gaussian or a normal distribution. Are we together? Then the other assumption that ANOVA should hold is that there should be homogeneity. So meaning the variance of the independent variables are approximately supposed to be equal. The variances must be equal, in short. That is another key assumption in ANOVA. So we also have other assumptions when you're dealing with ANOVA, which are as follows. That random sampling, it is assumed that the data that is collected in ANOVA should be randomly selected. Then also, there's an assumption of a balanced, for the balanced designs, that there should be equal sample sizes. So for a balanced ANOVA, each group should have the same number of observations for the analysis to be more powerful. And also we have what we call the categorical independent variable, where ANOVA assumes that at least one categorical independent variable with two or more level groups. So these are the basic assumptions that you need to know when you're dealing with ANOVA. Now I'm going to take you through what we call a one-way ANOVA and a two-way ANOVA. So let me take you first through the table, which is called an ANOVA table. Now for ANOVA, I need you to understand that for a basic layman, if we're dealing with a one-way ANOVA, we have columns, which we call treatments, T1, T2, T3. So these are treatments denoted by the letter K. Then we can have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So how many treatments do we have? The treatments are 3. These treatments are denoted by letter what? K. And we also have observations, total number of elements here, which are the observations. How many observations do we have? They denoted by the letter capital N. So the treatments are also called populations. So they ask you how many populations we have. There are 3 populations. And the observations, the total number of the elements, observations that are in there, we have 12. The variation, there's a variation that is within each treatment. So this is within. And we also have variations that are between. So this gives us a sample of how the ANOVA table will be. So there are 3 sources of variations. So we have in between the treatments. So this is sum of square between the treatment. Then we also have the variations that are happening within each treatment. So this is sum of square within. So SS stands for sum of square. Then we also have what? The degree of freedom. The degree of freedom for between is given by k minus 1. Degree of freedom for within is given by n minus k. And the degree of freedom for the total, this is just a total. You just add these two, which will give you n minus 1. I repeat, SS stands for what? Sum of what?
Squares.
Squares. DF stands for what? Degree of what?
Freedom.
Of freedom. Then we have MS, which stands for the mean of squares. MS, which is the mean of squares. So here we have mean of squares for the what? Between. Mean of squares for the within. These are just acronyms. MSW within. MSB between. And the final column is just for the F calculated, which we calculate by dividing the mean of square between divided by mean of square between divided by mean of square within. Now this is just a framework of the table that you need to understand. So suppose here we have how many? These observations are how many? They're 12, as we can see here. And the treatments or the observations here, how many? There are 3. Then they gave us actual figures for the sum of square between, for instance, they say this is maybe 40. Sum of square total, maybe they say this is what? 76. So they ask us to balance out this. So now using this framework, sum of square between, what are we going to put here? Sum of square between, what do we have? 40, right? So here we're going to put a 40. We've been given there. So sum of square between is 40. We'll put our 40 there. Sum of square total is 76. 76, that's the sum of square total. Then within is just a difference because the totals must add. So 76 minus 40, what do we get? 36, right? Then let's go to the degree of freedom. The degree of freedom simply says, use what has been given there. So k minus 1. What was our k? 3. So 3 minus 1, what we get? 2. Then here, we told n minus k. What is our n? 9. 12. 12 minus 3, what do we get? 9. Then the total, we just add these two. 9 plus 2, which is 11. Or if you want, you can simply say n minus 1. Our n is 12 minus 1 is 11. You still get the same answers. So balancing up is very easy. You just need to follow the steps. Then the mean of squares, you just divide the sum of square divided by the degree of freedom. So 2 into 40, what do we get? 20. 9 into 36, what do we get? 4. And finally, the mean, the F calculated is the mean of square block between over the mean of square within. Just divide this answer in there. So 4 into 20, we get a 5. So F calculated is equal to 5. Let's start afresh. We're given what? 40 and 76. Can somebody remind us, how did we get the 36?
It's the difference between 76 and 40.
Yes, difference. Right? Then, how did we get these 2 and the 9?
The treatments of observations, the K, there are 3.
Hmm?
K minus 1 is 2. Then N minus K, which is it 12 minus 3? It's 9.
Okay. Then the 11.
2 plus 9.
Right. Okay. Then how do we get the 20 and the 4?
We divided, is it the SS by the degree of freedom? I don't know. The degree of freedom K minus 1, which is 2 there.
Good. So the mean of square block is simply the sum of square between over K minus 1.
Okay.
The degree of freedom there. So it's simply, like you said, SS over DF. So 20 over, or 40 over what? 40 over 2, which is 20. And the mean square within, it was simply sum of square within over N minus K. So here we simply had what? 36 divided by what? 9, which is 4. And finally, how did you find the F calculated? How did you find the F calculated? Makung, are you there? How do you find the F calculated?
We divided the MSD by the MSD.
20 over what?
Wow.
Right, which is 5. All right. So sometimes the examiner will just be tricky to see whether you understand the concept. So they'll not give you anything there. Maybe they'll just rub there. Okay, then they'll just rub maybe here. All right. Then they'll just rub there. They'll ask you to fill in the blanks. So F calculated here is 5. So let's move the reverse way. So how do we get the answer here? The difference, right? 86, correct? Then how do we get the blank here? So we know that the answer, this divided by that, we got that. So to get that answer, how did we get? So we divide this divided by that, isn't it? To get a 2. How do we get that? Then how do we get this? We just add 30 there. All right. So they've given us. So here, how do we get the figure here? We divide this into there to get what? A 4. So therefore verifies that. Are we together so far? Now, especially for you, Makongus, your assignment. Lead us through filling in this table. Okay. So we're told that a researcher comparing 3 treatments with separate sample N is equal to 6 in each treatment. An ANOVA is used to evaluate the data. The results of the ANOVA are represented in the complete or the missing. Hint, begin with the degree of freedom. They're even spoon feeding you. So we've been told that what? There are 3 experiments. So here, our K is what? 3. Then we're told that N is what? 6. So let's start from here. What are we putting here? Anyone? We're told that there are 3 treatments. Makongo, so what are we putting here? If K is 3?
It's K minus 1. which is 3 minus 1.
Yes, to get what? Correct. What else? So we're told that there are 3 treatments. So K1 or T1, T2, and T3. What else are we told about this? That this within separate each treatment as 6. So here we have 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is 6 by 3. What is our n? 18. So what are we going to put here if our n is 18?
It's 18 minus 3, which is 15.
The 15 will come here, n minus k. All right. But here what are we going to have?
17.
17, n minus 1, or just to bring totaling up 17. Are we together so far?
Yes.
Or can we go together? All right. Then how do we get, now we can connect, it's expression paper 2 is one. So how do we get the answer here given this one? So this one into that one, we get that one. So to get, we do the opposite, we multiply. 15 times 4, what do we get?
60.
60. All right.
Yes.
So is it verifying? 15 into 60, is it getting a 4?
Yes.
Yes. So can somebody try? So now here, we now go to this one. What do we get here? How do we get this figure here?
The difference.
Excellent, the difference. So 92 minus 60, what are we getting?
It's 32.
32. Then how do we find the mean of squares?
Divide the SS by the DF.
Yes, so this and there, what do we get?
There I will get 16.
16, correct. Then finally, how do we get the F calculated here?
We're going to divide the MSW into the MSD. That's 50.
Divide the mean
4.
between over within. So 16 over 4, what do we get?
4.
4. All right. See how easy it is? All right. Now, let's go to the instance where we're not given those figures. For instance, we're given A, B, C. And we're told that this is 2, 4, 6. This is 1, 2, 1. This is 3, 2, 2. So if you're not given the totals, you need to calculate them on your own. So let's sum them up. We find the individual totals and we square them. That's the first procedure. So here, what are we getting? 12. How many are there? 1, 2, 3. Put 3 there. Then you square them individually. 2 squared plus 4 squared plus 6 squared. So this is 4 plus 16, 20 plus 36, 56. Right. Can you help me in this column now with the procedure that I've just given you? What are we doing?
4. So the summation of x is 4.
Oh, correct.
N is 3. Then 6.
Square this square, that's square. So 6, correct.
6.
The lead is here.
It's
Quickly.
9. The summation is 9.
Summation is 9. Are you agreeing with him?
So sorry, 7. Sorry.
Mm-hmm.
7.
Yes. Okay. So here, when you add them, you get 7. Yes. Then
3.
then
17.
17. Then let's get the totals now. So summation of x, summation of up to n, and summation of x squared. So this plus that, let me start with the easiest. It is 9. So you give me the totals there and the totals there.
Summation of x 23.
3.
Uh, 79.
79. This you have done half of the work already. So you need to find only 2 things. Sum of square total, the formula is simply summation of what? X squared minus summation of what? X to the power 2 over n. So here we have 79 minus 23 over our n is what? 9. So calculate for me. What are we getting? 23 squared divided by 9.
20.2.
So this will be 79 minus what? 58.7.
58.8. Or 0.7 or 0.8.
So what we get is 20.22, right? So sum of squared is 20.22. So this is how we find the sum of square total. Sum of square treatment, we are calculating each treatment over its sample size minus the correction term, which is summation of x over n. So here what we're doing basically is 12 squared over 3 plus 4 squared over 3 plus 7 squared over 3 minus 23 squared over 9 individually. So 12 squared over 3. The next one was what? 4 squared over what? 3. Next one was what? 7 squared over what? 3 minus 23 squared over 9. So what are we getting here? And calculating? The calculator here, please calculate.
So I'll give the final answer. It's 10.8. 10.89.
10.89.
Yes, 10.89. I don't know if that everyone has found that one.
The ladies were not participating. So 12 squared plus 4 squared plus 7 squared divided by 3. We are going to have what? 69.67 minus 23 squared divided by 9. Here we're going to have 58.77. So when you get the difference, you're going to get 10.8 what?
10.89.
Correct. So this is sum of square treatment. The treatment is also called between. These are treatments. So sum of square between is what? 10.89. So we have three things now. Sum of square between 10.89. Sum of square total was what? Sum of square total was what? 20.22. Somebody tell me what is our K and what is our N? What is our K here and what is our N? What is our K?
3.
3. And what is our N?
9.
9. Here we have a 3 and here we have a 9. So who can set up the ANOVA table for us? So we have source. What follows after source?
Of squares.
Yes. Squares, yes. Then
Degree of freedom.
degree of
freedom.
freedom.
Mean of squares.
Degree of squares. Then
F
calculated. So what are the three sources? We have between, then within, then the total. So what is our sum of square between?
.89.
0.89 in total. 20.22. How do we get the within? We subtract. So what do we get? 9.33. And here, what do we put? Degree of freedom?
K minus 1.
K minus 1, which is what? 2. Then here, what do we put?
8.
Is what? Here?
8.
8. Then here? Get 9 divided by 2, which is what? 5.445. Here, 9.33 divided by what? By 6. What? 1.55. Then we divide this in there. 5.445 divided by the answer. We get 3.502. Okay. Then you can also learn how to read from the table using the coordinates here. If you are given 5%, what are the coordinates here? 2, 6. So I need to teach you how to read this table. The F table, you'll be given a percentage. It can be 1%, it can be 2%, it can be 10%, but you use these to read that table to understand the readings. So the tables will be given usually to you to interpret. So F tables are usually found at the end. So let me beam some statistical tables which look like this. So you go at the end. Make sure that you are sure of the percentage you are given. So F tables here, there's a 5 table, there's a 1% table, there's a 0.1 table. So here we are looking at 5% table. So 5% table. So our coordinates in this case are what? 2,5. So what it means is the 2 should come in the horizontal. So this is for the treatment, and this for the horizontal. So 2,6 where they meet. That is where the reading is. So we'll go into the table here. 2 is coming on top. And 6 from the horizontal here where they're meeting. What is the reading? 5.14. I repeat. In our previous instance here, for instance, if we were given to read under the significance level of 1%, what would be the readings? The F at 1%, what are the coordinates using this table? 2, what? 9. So 2 is coming from the top, then from the horizontal, there's a second one there. So we go into the F table, first look for 1%. 1% is the title, here it's 5%, we can't use this one. This one continued on 5%, we can't use this that one. It is 1%, correct. So it is 2, what? 9. So 2 is coming from the top, the 9 from the horizontal. So where are they meeting? 8.02. So I'm just teaching you how to read these tables in case you're given. So that is called the F statistics. All right, so that is where the 8.02 is coming from. So our decision is always to reject our HO. Whenever this is greater, we reject. Whenever this is less than what we found in the table, we accept. So this is 2,6 under 5%. Let's go again. How did we find the answer? 2,6 under 5%. So let's go to 5%. Back. It's 5%. So 2,6, it is at 5.14. So we go here 5.14. So is this greater than that? No, it's less. So we do what? We accept. So you need to follow a 5-step procedure in now answering this Anova question. So remember the Amen treatments. 1, 2, 3. The 3 treatments. So step 1, you state the hypothesis. The procedure is just standard. So you say step 1, let's say HO is mean 1 is equal to mean 2 is equal to mean 3. And the alternative hypothesis, just say at least one is different. Step 2, state the level of significance. Our level of significance here is what? 5%. That's all. Step 3, state the decision rule. What we found in the table here was what? 5.14. So just say we will only reject our HO if our F calculated is more than what? 5.14. So it says reject HO if F calculated is greater than 5.14. In step 4, we calculate our F calculated. What was our F calculated? The one we calculated here, 3 point what? 3.502, or if you want, you can bring the entire table on step 4, because what we need is the F calculated. Then finally, step 5, we make conclusion. So since our F calculated is less than 5.14, what we do? We accept HO. That's all. So this carries about 20 marks. So this takes us now to your class exercise or assignment here. So we've been told at 5% or 0.05, determine if there's any difference between the means. So you can see these are the means. So I want us to do it together to come up with the F calculated. So we're given in that question 3 categories. So 3 groups. We have treatment 1, treatment 2, and treatment 3. 1, treatment 2, and treatment 3. So here in treatment 1, we have what? 527, 163, 222, 334, 055, 132, 204, and finally 235. So they're squeezed up. So let's find the 3 things. What do you first find? Summation of x, n, and summation of x squared. Who wants to help? Column 1, what are we doing? First, what are we going to do? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is 5 and 7, 163, 2, 22, 3, 3, 4, 0, 5, 5, 1, 3, 2, 2, 0, 4, and 2, 3, 5. So let's find the summation of x, n, and summation of x squared. So let's go quickly. Summation of x, we're just adding up in there, right? 5 plus 1 plus 2 plus 3 plus 0 plus 1 plus 2 plus 2. Now we're getting 16. How many are they? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 here. Then next we're squaring individually. 5 squared plus 1 squared plus 2 squared plus 3 squared plus 0 squared plus 1 squared plus 2 squared plus 2 squared. We're squaring individually. We get 48. We go back here. 2 plus 6 plus 2 plus 3 plus 5 plus 3 plus 0 plus 3. In total up here, we're going to get 24. How many are they? There are 8. Then we're squaring them individually. 2 squared plus 6 squared plus 2 squared plus 3 squared plus 5 squared plus 3 squared plus 0 squared plus 3 squared. You square them here, you're going to get 96. And we'll go to the last column here. 7 plus 3 plus 2 plus 4 plus 5 plus 2 plus 4 plus 5. You're getting 32. And here there are 8 already. Then we'll square them now. 7 squared plus 3 squared plus 2 squared plus 4 squared plus 5 squared plus 2 squared plus 4 squared plus 5 squared. What we get is 148. Then we sum up the totals there. This is 16 plus 24 plus 32. So here we have what? Sum of x, which is 72. And 8 plus 8 plus 8, but n is what? 24. And here 48 plus 96 plus 148. What we get here is what? 292. Are we clear together at the moment so far?
Yes.
So how do we find the sum of square total? Who remembers the formula? Sum of square total. Summation of x squared.
Squared minus
2 over what?
n.
So here we have what? 292 minus what? 72 squared over n, which is what? 24, right? So 72 squared divided by 24. So 216. So here to be 292 minus 216. Okay. We're going to get 76. Then we go to sum of square what? Treatment, which is same as sum of square between. Okay. Sum of square in each between over n minus sum of square correction term. So here, which ones are we moving? 16 squared over what? 8. Plus what? 24 squared over what? 8. Plus what? 32 squared over what? 8. Minus what? 72 squared over what? 24. So 16 squared, the shortcut just 16, if the denominator is the same, 16 squared plus 24 squared plus 32 squared, we divide by 8. So this is 232 minus 216. Since this is the same correction term that we have there. So here we're going to get 16. All right. So now this is sum of square total. Sum of square what? Between. And our n, what is our k? Our k is what? 3. Our n, 24. Now, actively participate here. So sum of square total, sum of square between, sum of square total, our k, our n, right? So what is the sum of square between? 16, then 76. 16, 76. And here we have what? 3 and 24. All right. And according to the question, what is our level of significance? 5%. 5%. Level of significance 5%. So we'll put 5% here. So let's follow the steps. Step 1, state the hypothesis. Hypothesis is based on the number of what? Of treatments. So just say mu1 is equal to mu2 is equal to mu3. Then here say at least one is different. If our K was 5, would have gone up to mu5. If our K was 10, would have gone up to 10, because this one determines our number of means. Step 2, state the what? The level of significance here is 5%. Step 3, our decision rule, we need to first calculate the degree of freedom there. So I don't know the degree of freedom yet, but step 4, we need to come up with an Anova table. We will identify the degree of freedom after we get the Anova table. So we have 3 sources of variation. What are they? The 3 sources of variation: between, within, and what? Total. So here we have sum of square. Here we have what? Degree of freedom. Here we have what? Mean of squares. Here we have what? The F calculated. And here I've modified it just so the F calculated and the decision. So sum of square between is 16. Sum of square total, 76. Makungu, how do we get within there?
It's the difference. 76 minus 16.
Which is what? 60, correct? How do we get the degree of freedom there?
The K minus 1. So our K is 2.
Which is 2.
And then
And
write the N minus K. The 24 plus
1, yes. And here, the 23. And here, what do we get here? We divide this in there, 8, and here 60 divided by 21. What do we get? 587. All right. Here you don't get the total. Then finally this in there, 8 divided by answer. What do we get? 2.8.
That's 2.857.
Yeah, because I didn't round off. It's also. Then what are the coordinates here for the F tabulated? So 5% against what? 2, what? 21, right? Where's the 2, 21 coming from? From here. 5% was given at alpha 0.05. So let's read 2, 21 in the table. Any questions so far? Are you following so far? So let's go to the table. 2, 21. So 2, 21, one is there. So this is 3.47. So 3.47. So we say reject HO if F calculated is what? Greater than 3.47. 3.47. So what is the decision here? Do we reject or we fail to reject? So whenever we reject, the answer is in the rejection region, meaning there's what? There's a significant difference. Whenever we fail to reject, it's like accepting. Yes, it's accept region. There's no significant difference. So here we can see this one is smaller than that, so we fail to reject. Same as accept if you want to say. So you can say step 5 now. Since F calculated, which is 2.8, is what? Is less than 3.47. At significance level 5%, we do not have sufficient evidence, or we fail to reject in your own language. Fail to reject what? HO. Whenever we fail to reject HO, it means there's no what statistical difference between the means. So there's no statistical difference between the means. In the means. All right. So this is how this question was supposed to be tackled, Makungu. I hope it helps a lot. So this is how they're supposed to use a 5-step hypothesis procedure. State the hypothesis, state the significance level, the whole process as we've done them. Right.